this fourth and last video, we'll cover problem 112, which was done in today's class, April 15th. This problem we have to solve what is written there, so you should go to the problem set and look at it. So demand equals to supply and some initial conditions. Demand equals to supply gives the following: plus p minus 3p prime plus 3p double prime equals to 20 plus p minus 2p prime. Okay, what I'm going to do, I'm going to move everything that has p to the right hand side and what doesn't have p to the left hand side. So on the left hand side we have 12 e to the minus t minus 20 equals to, on the right hand side, first what it was there, p minus 2p prime plus 4p double prime, and everything here moves to the other side with signs changed. What is positive moves as negative, and what is negative moves as positive. Minus p plus 3p prime minus 3p double prime. So 12 e to the minus t minus 20 equals to, these guys cancel, the second derivative is 1 left, and this 3p prime minus 2p prime is plus p prime. So this question to solve in terms of y is y double prime plus y prime equals 12 e to the minus t minus 20. We start as usual with the first step, which is the homogeneous equation. Y double prime plus y prime equals to 0. This is a degree 2 equation because we have a second derivative. Therefore, the characteristic equation is a squared plus a squared because of y double prime, plus a because of this, and there is no y, so there is nothing else, equals to 0. Common factor a plus 1 equals to 0, and we get a equals to 0, a equals to minus 1. And from here we have the first solution, which will e to the 0t, but this is simply e to the 0 or constant 1, and here e to the minus t, from which we have that the homogeneous equation has solution a constant times 1, so c1 plus c2 e to the minus t. The second step is to solve the particular solution. Now, for the particular solution, we have this equals to 12 e to the minus t minus 20. If you remember, you always write this as a polynomial times an exponential. But this expression here is not a polynomial times an exponential because here we have e to the minus t and here we don't have it. Something is wrong. So to solve this step 2, we divide it in two parts. We first solve this equation with 12 e to the minus t and get a solution which I'll call y1, and then we solve the equation with minus 20 and get another solution I call y2, and my particular solution will be the y1 plus y2. So let's do it, and let's start with this equation, y double prime plus y prime equals to 12 e to the minus t. This is written as usual a polynomial, which is 12 e to the mu t. This is e to the minus t, so here mu is equal to minus 1. And k is the number of times, this is the number of times this mu minus 1 is a solution of the characteristic equation. Now, if you look up here, the characteristic equation has solutions a equals to 0 and a equals to minus 1. So here, let me erase and write this more neatly. So a equals to minus 1, that was done before. So this is a solution, so k is equal to 1. Changing color to green, we have for the particular solution a polynomial of the same degree, which I'm going to call a, e to the minus t, and t to the k, which is t to the 1, or simply t. And from these three, I got y1 is a t e to the minus t, the product of the three of them. How do we find this constant a? Is just by going to the equation. So we have y1 double prime plus y1 prime equals to 12 e to the minus t. Okay, y1 is simply at e to the minus t. So the derivative is the product of two things, so will be derivative of the first factor times the second plus the first factor times the derivative of the second, which is e to the minus t, with a minus for the exponent, so it becomes at minus at e to the minus t. The second derivative will be here, derivative, this is e to the minus t. So let me erase it and write it properly. E to the minus t. So will be derivative of that, a e to the minus t with a minus, minus derivative of, this is again a product of two factors, derivative of at is a, and the other one I don't take derivative, minus at, derivative of this is e to the minus t with a minus. So the whole thing becomes minus a e to the minus t minus a e to the minus t plus a t e to the minus t, or minus 2a e to the minus t plus a t e to the minus t. Once you have that, we have to solve this equation here. So we have the second derivative, minus 2a e to the minus t plus a t e to the minus t. This is y1 double prime, plus the first derivative, which is here, a e to the minus t minus a t e to the minus t, that's plus y1 prime, equals to 12e to the minus t. With that, we do the operations, and we have minus 2a e to the minus t plus a t e to the minus t plus a e to the minus t minus a t e to the minus t equals 12e to the minus t. This guy cancels this guy, and minus 2 plus 1 is minus a e to the minus t equals 12e to the minus t. A is minus 12, and my solution is equals to, remember, the solution was a times t e to the minus t. Don't forget this t here. We go for the second one. The second one will be y2 double prime plus y2 prime equals to minus 20. Again, we write this as a polynomial in t, which is minus 20. We write e to the mu t. It doesn't appear, so mu is equal to 0. And k, remember, the characteristic equation has solutions a equals to 0 and a equals to minus 1. So the 0 is once is there, so k should be 1. I change to green as usual, and what do I have? I have q of t is a constant, let me call it b. Here e to the doesn't appear, so we don't e to the 0, which is 1, and this is t to the k, which is t to the 1 or t. And our second solution should be bt. Now we try to compute this constant b. In class I call it a, but here it doesn't matter, it's b. So it's y double prime plus y prime equals to minus 20. So from here you have y prime is equals to b, so and y double prime is equals to 0. So 0 plus b equals to minus 20. B obviously minus 20, and my second solution here is minus 20t. Don't forget the t, because you can look at it, here is the t. The homogeneous and the particular solution, we go to step 3, which is our solution is the homogeneous plus the particular. Remember, this particular is the addition of the first plus the second. Let me write this in terms of p. So p of t will be, you look at the homogeneous, stop here, look at the homogeneous, will be constant 1 plus constant 2 e to the minus t plus the particular. The particular, if we look up here, we have the first is this one here, minus 12t e to the minus t minus 20. And now we go to step 4. Step 4 requires to use the initial conditions to solve the problem. The initial conditions for this problem are simply p of 0 equals to 12 and p prime of 0 equals to 2. What do we have? P of t is written up here, so we compute p prime of t, which from this formula is the derivative of c1, 0, plus c2 e to the minus t minus derivative of 12t times e to the minus t minus 12t e to the minus t. Derivative of this is minus. And sorry, this is minus 20t. So this will be minus 20. Okay? So what you have, simplifying the signs here, p prime of t is minus c2 e to the minus t minus 12 e to the minus t plus 12t e to the minus t minus 20. Now we put 4 times 0. P of 0 is equals to 12. And we go to the formula of p, which should be visible here. If not, you go to your notes. Will be c1 plus c2 e to the 0, which is 1, minus 12 times 0 minus 20 times 0. And p prime of 0, which is 2, is here, and is minus c2 e to the 0, which is 1, minus 12, plus 12 times 0, minus 20. So we have to solve c1 plus c2 is equals to 12, and minus c2 minus 12 minus 20 equals to 2. From the second one, we have minus c2 equals to 2 plus 12 plus 20, which is 34. c2 equals to minus 34, and c1 plus c2 equals to 12. So c1 is 12 minus 30 minus c2, which is minus 34. 12 and 34 is 46. And we have the the solution of this is right here, c1 46 plus c2 minus 34 e to the minus t minus 12t e to the minus t minus 20t. And that completes the problem fully. Remember, for this type of equation is the homogeneous. Then the point here is solves the equation, but maybe not your initial conditions. And then homogeneous plus particular, your solution, and this plus initial conditions solves your problem. It's very important to understand that this is a solution of the equation that does not necessarily satisfy your initial conditions.